Hello, I'm Carlos with Fiveonefour. I've been working with my fellow team members to build a demo of an operational data warehouse. The demo is part of our area code repo, which is available on GitHub. If you'd like to check it out, make sure to view the links to the code at the end of this video. This demo is based on an operational data warehouse, or ODW, which is the type of data warehouse designed to support real-time and near real-time operational decision-making. Unlike traditional data warehouses, which focus primarily on historical analysis and long-term trends, an ODW emphasizes up-to-date information for daily business operations. Today, I'll present a workflow that converts unstructured data to structured data using our Fiveonefour Moose framework and the Claude Sonnet LLM. While this isn't strictly something you'd see in an ODW, it is a classic ETL process that would be used as part of various kinds of data warehouses, including ODWs. This video represents one of our continued iterations to demonstrate how you'd use the Moose platform to build an ODW. In a future video, we'll demonstrate how our unstructured to structured data process sets the stage for related business decision-making. Our implementation spans three sub-projects. There is the DW front-end, the user interface for managing unstructured data by triggering back-end processing workflows and viewing the results on the dashboard. The data warehouse backend is the Moose-powered application that drives backend processing. The backend in turn uses the library of connectors. There are sample connectors for logs, blobs, and event objects. In this presentation, we'll look at our newest member of our data connectors group. It's an S3 connector that communicates with a local S3 compatible object store called Minio. As a side note, you could swap the S3 connector's credentials to use your remote S3 compatible stores such as AWS. On the right side of the screen, we see a screenshot of our ODW's Data Warehouse Unstructured Data Connectors page. And just below it, there's a screenshot of the Minio S3 compatible object store dashboard. Behind it all is a local ClickHouse OLAP-DB where we'll store our unstructured data models and structured models. For this demo, we've created a simulated and highly contrived scenario where a group of receptionists work at a dental office supporting a team of doctors. Each receptionist sends a group of messages to doctors in the form of memos. Each text memo is written slightly differently, but generally contains the information each doctor requires. Our task is to take the unstructured memos and convert them to structured data that can be stored and queried in a database. For this data automation task, we'll use the Claude Sonnet LLM for data extraction via a Moose workflow process. Next, we'll briefly examine the data flow between various components. Now, before you step back and think, that's a whole lot of moving parts, consider that these are embedded modules and well-packaged components that spin up and down using simple one-line commands. More about that later. On this screen, we see the data warehouse front-end. To the right of it is a screenshot of the web front-end. The user specifies the location of the S3 data that they want to process. That request goes to the Moose Egress API endpoint, which in turn creates a Moose workflow. The workflow is highlighted here with dotted lines to indicate that it's a central driver of the data processing work that needs to happen. We see that the workflow is able to access our OLAP database on the left, utilize the S3 data connector on the right, which provides read access to the external S3 object store. That's where the unstructured medical memos are stored. To the far right, we see a screenshot of the object store showing a list of memo files in tiny print. Returning to the Moose workflow, we see that it has access to a Claude LLM, which it will use to process the unstructured memos it receives via the S3 data connector. When the LLM creates a structured data JSON object, it's converted to a medical data model, which is sent to the Moose Ingress API, where it's sent to the ClickHouse OLAP-DB via Red Panda. This architecture stages a production-grade approach enabling high-volume data processing. Feel free to return to this diagram at any moment in the video. For now, let's see all of this in action. The repo for this demo is available under our Fiveonefour GitHub account under area code. After git cloning or downloading the area code repo from GitHub, we'll cd into the ODW folder. I'll use the tree command to view the folder structure we'll be working with. Here we see an app folder, which hosts our Streamlit-based data warehouse web frontend. We also see a services folder, which contains a connectors folder and the data warehouse folder. Let's cd into the services data warehouse folder where we have a setup helper script. The setup supports a series of commands. Here we see the first time setup. You can start and stop and restart the data warehouse services. As a quick note, I won't cover every command and setup detail in this video, so make sure to look at the repo's extensive documentation for a better sense of what's required if you'd like to try this yourself. If you're running this for the first time, make sure to use the setup.sh setup command to install the local dependencies. I've already done so, so I'll use the setup.sh start command to start this demo. So here the setup script starts. It's loading services. It's about to start Moose. Moose just started. And then it's now starting the Minio. Loading other containers for Kafka. And here we see the result. Here we see that the data warehouse service is started on localhost 4200. That is the Moose service. We see the data warehouse front end on 8501 and other services listed, Minio.io listed on 9500 and 9501 for its console. And we see ClickHouse, Redpanda, and Redis containers. So a number of services loaded inside of containers. If you're running this for the first time, you'll need to also run the one-time seed script, which will build the medical memos and load them into the local S3 data store. We can confirm that data has loaded by navigating to the Minio S3 dashboard and signing in with Minio admin as the username and Minio admin as the password. Let's do that now. We'll accept the license. And here we see in the unstructured data, we see that we actually have files loaded. We can click on these files to view them. And we can see the unstructured memos are indeed inside the unstructured data S3 compatible bucket. Now, if we navigate to our data warehouse dashboard and we click on the unstructured page tab, we can go ahead and enter an S3 path to unstructured data. And let's see, that looks good. So I'll click on the process button to initiate this request. And then we can press on the refresh button. And we see that records have indeed been processed. We can see the structured columns extracted from the data. But more interestingly, if we click on one of these buttons here, on one of these checkboxes, we can actually see the medical record, and we can see the structured data that resulted from it. So in this example, we see that this is Dr. Carter. If we look in here, yes, indeed, this is Dr. Carter. And the patient's name is Sandra Rodriguez, and here it is. There's the patient's name, and she is 41 years old, and yes, 41 years old is extracted, phone number is extracted, etc. And so it's an example. We can click on others and sort of see this different records appearing, and for different treatments, different dental procedures. And so it's just an example of data being processed from unstructured data to structured data, and in a format that can be queried. Okay, let's have a look at some of the code. So here in Cursor, if we look at the DW folder, under apps, we have our DW front end. We'll look at some of that in a bit. We have our services. Under services, we have our connectors and our data warehouse. So let's start with the DW front end. We can see where things initiate from. And so when the submit button is pressed, we'll look at that. So in the unstructured data view, that's the page that has the button. When the button is submitted, that is the process button, we see that a call, see if I can find this, we see that a call is made to trigger the Moose Consumption API, and the name of that API endpoint is extract unstructured data. So that's what's happening from the front end. This is basically triggered. It's ultimately an HTTP call, calls a consumption API, and that's the name of it. And so if we come over to the right side here, sort of collapse that, and let's look at the data warehouse. Under data warehouse, we can look at apps, and we will look at APIs, right? Because it is an API that we're after. And here it is, the extract unstructured data, which I have open here. If we look at that, let's see. Yep, here's a function. So this is the function that is defined to handle that call. So what happens is submit button is pressed, data is passed, data is received here in the back end where these workflow parameters are constructed. This will be the information that is being passed into a workflow that we initiate. That initiation happens down here on line 50, where we execute a workflow called unstructured data workflow and pass it the workflow parameters. So let's look at how these workflows are created. So at this point, we're able to see that front end is making a call, is sending some data to the back end extract unstructured data API endpoint is receiving that data. And what it does is, we see here, what it does is it actually executes a workflow. But let's look at how these workflows are actually created. I think that is the meat of sort of this processing. And so if we look into, actually, let's look at it from this perspective. Here's the unstructured data folder. This is really where the workflow for unstructured data lives, and it's inside of, rather, it's defined inside of the extract Py function here. And so let's just jump to the very bottom. Sorry for that fast scrolling. So a workflow is very simply defined by using the Moose workflow function. It's given a name, and we know already that it is the unstructured data workflow. We saw that earlier. And then we configure the workflow in this way. And the configuration for the workflow really is, hey, what is the starting task that the workflow will execute? And so we see here that that is called unstructured data task. We see that here. Here's a task definition for it. This is where the task is being created. And so really these two are working in tandem, right? We first define a workflow, then we define a task, and the task is configured to be this function. So that's the entry point into the task, which very conveniently, we see just above here. So this is really the meat of what this workflow that's defined is actually doing. And so this particular workflow has two phases or two stages. The stage one is extracting files from S3 and creating this unstructured data to stage these records, right? So this is the loading of unstructured data in phase one of this workflow. The second phase of the workflow processes the unstructured data records and creates medical records, which is the structured data, using or with the assistance of an LLM to do the actual data extraction. So again, two phases. We can look at the first phase function here. And here's the definition for that function. Of course, we do a lot of logging in order to really show the progress and what's happening. Very cool thing here is that this workflow is using a data connector factory that it can choose from many different types of connectors. In this case, it's looking for or requesting that the factory pass it a connector of type S3. So this is really the S3 connector that we're going to be working with, right? And so if we look over on the navigation side, but actually, excuse me, it's in connectors. So these are our connectors. We look at some source for connectors. We see we have various types of connectors, including S3 connector related functions, the connector itself and a file reader. Taking a quick look at this file reader for a second, we just see that it is using Bottle3, which is the, I guess, most popular S3 connector under Python. So it is, in fact, a legitimate connector that the connection or connector factory is returning, again, for use. And so that is, if we scroll down through this, essentially the connector retrieves files. And so it builds this unstructured data from the files that it loads. And so this is a really good opportunity to talk about Moose data models, because all of this includes type safety. And so we build data models for the data that we're moving into in and out of database and all kinds of streaming functions and other ways that we use this, but it's always with data that is typed and defined. So if we look at models, and models is actually defined in the ingest folder. Here we are, ingest. Under models is loaded right here. So if we look at this, we see this unstructured data model is actually defined here. So this is the unstructured data. We define it, define the fields that should be present and expected. So going back to the extract, that's what's happening here. Each file is loaded. It's loaded into an unstructured data model. Okay, so here in line 215, we see that we're taking the files, all the records, the unstructured records, and we're sending them to the local Moose ingest at the unstructured data endpoint. So this is really how the data is being sent to the ingest for unstructured data, and how the data ultimately gets into the database as unstructured data records of this type. So going back, and let's jump over to stage 2. So in stage 2, those records are actually retrieved. The unstructured data records are retrieved from this get structured data endpoint. So again, ingest and egress features of Moose are being used to both save information and retrieve information. In this case, we're retrieving those unstructured data records. Here's where we get a handle to the LLM service that we're using. That's the Claude service. And for each of these unprocessed records, we're essentially building a batch to send to the LLM. So here we call the extract structured data in batch form and passing it the batch that we want processed along with processing instructions, right? And so after that, we end up having the LLM returns batch results. And so we enumerate through batch results and ultimately take the results of this extracted data for each of the batch items, and we build a medical record. Medical record is defined inside our models folder here. And here's the medical record. So again, from unstructured data, we get extracted data, and we load it into the medical data structure there. And for each of these medical records, we essentially send them to the ingest for medical records, where those medical records get serialized. And that really shows you the use of Moose in various stages, working with unstructured data and moving that data into structured form, and making it available from the front end through queries. Well, that's it for this video. Check out the code for the project and visit our Moose doc pages to learn more. Thanks for watching.